evaluate the integral of sec x dx. Now this one is quite more complex than the other numbers that we've been doing before, because here there is no straightforward way, but we're going to have to use a unique kind of use substitution in this case, but it's actually doable. So for this case, we're going to multiply and divide the integrand with sec x plus tan x, and that is because only these can actually bring out something in use substitution that will cancel out with the value that we actually have up here, but you understand it as we work it out. So just know that this has properly been researched on, and it has been confirmed that this is the best way to handle this. So we'll always multiply and divide the integrand with sec x plus tan x. So this is what we have. So we've multiplied the integrand, so we've multiplied it with sec x plus tan x at the numerator and at the denominator. So this is what we have right here. Now basically, because it's like this, it means we've not changed the meaning, because this and this can actually cancel and we'll be left with sec x. So we've not changed the meaning of the question. So this is actually okay. Now we can actually clearly see that we can multiply this sec x inside these brackets and we'll have sec squared x plus sec x tan x. And now that we have this, we can actually now get a value that will actually cancel out with something in the numerator. So now clearly we can now let u to be equal to sec x plus tan x. So du dx shall be equal to, so actually we've let u to be equal to this numerator value, which is sec x plus tan x. So we can say du dx shall be equal to, so the derivative of sec x is sec x tan x, and then the derivative of tan x here is sec squared x. So we have sec x tan x plus sec squared x. And then if we make dx the subject, dx shall be equal to du over sec squared x plus sec x tan x. And this will work, and you can say this clearly is going to cancel out with what we have at the numerator. So now we plug everything back, we can say this will actually work for us. So this will actually cancel with that, and we'll be left with the integral of 1 over u du. So this is the best way to actually work out this number. So the integral of 1 over u is going to be ln u plus c, but remember that u is sec x plus tan x. So therefore our final answer is ln sec x plus tan x plus c. So this is how we solve the integral of sec x.